Hello, and welcome to another episode of OpenNMS 101, the training course that hopes to bring you up to speed on the OpenNMS network management platform. In this lesson, we're going to discuss SNMP traps. Now, I assume you've watched the previous lesson on SNMP, or you're familiar with SNMP traps, but SNMP and OpenNMS is many things. The two major things are events from SNMP, which are called SNMP traps, and the other thing is performance data collection. Now, this is my my system that I've been running on my VM, and if you remember, we have our node, and in the last episode, we enabled SNMP. Well, it's been running for a couple of days, so now I can click on resource graphs, and I can look at node level information, let's say, and this will show me a nice little graph of things like TCP errors, segments, context swapping, number of processes, total memory, number of users, interrupts, etc., system uptime. And this is always done, this is done automatically. Like, I didn't have to do anything special. All I had to do was enable SNMP, and it turns out that all this data is already pre-configured in OpenNMS, and we get these cool little reports that show us what's going on with this pretty idle system. There's not much going on at all in this system. Now, for this lesson, we want to talk about the other half, which is the event side. And so OpenNMS can receive SNMP traps. Now, unfortunately, the Internet Engineering Task Force hasn't seen fit to require all the vendors to use a unique event identifier so that it would be easy to map to OpenNMS. So we have to map our stuff manually, and we do that using a mask. So traps will look at certain aspects of the trap that come in and will map it to an event. Once that event is in OpenNMS, it's pretty much the same as any other event in OpenNMS. So you can do alarms, you can do notifications, everything like that. So many traps are predefined. So let me go back over here to my system, and I'm going to do a service SNMPD restart. Yes, I'm still an old guy, so I don't use much in the way of system control, which is what I should have used there. But now if I go into my event list, I just restarted the SNMP trap daemon. And as you can see, there's the shutdown trap. That comes from NetSNMP. So when NetSNMP agent shuts down, it sends this shutdown trap. And then we've got this cold start trap. Now, what does cold start mean? If you will actually look, I assume you guys still have your handout. So if you look at the handout on the back page, so you've got your MIB2 on one side. On the back page, you'll see there is all the different commands for SNMP version 1. There's 5 of them. There's a get request, get next request, get response, a set, and a trap. Now this middle section here breaks down the traps. You identify a trap usually with 3 items. First, there's an enterprise ID. So the enterprise ID is a number that defines the trap. Usually traps are defined in a MIB provided by the vendor, and they will set the enterprise ID. Because it's a vendor-supplied MIB, almost all the enterprise IDs will start with .1.3.6.1.4.1. something, which, if you remember from the last lesson, is our private enterprise branch. Now that next number will tell us usually who the vendor is. Now the second value, so enterprise ID is the first value. The second value is the generic type. And there are a set of generic traps out of the box. 0, again, this is ordinal, so 0 is cold start. And this means the SNMP agent was started from scratch. A warm start, which is type 1, is that the SNMP agent was like warm restarted, so you could just say you did a reload of a config or something like that. I've never really seen warm start on NetSNMP. It's usually just a cold start. The next two, type 2 and type 3, are link down and link up. These are very, very common. So if I go and unplug a cable from a switch or a router, that'll usually generate a link down trap because we lost the link light. Plug it back in, that's a link up. So cold start, warm start, link down, link up. Very, very common. The fourth type is annoying. It's called authentication failure trap. This is a trap that gets sent if someone tries to access your SNMP agent and they don't have either the right community string or they're not coming from the right IP address. Most agents will allow you to turn this on or turn this off. I think they're on by default on a number of agents. the reason I say they're painful is that you can get a lot of authentication failure traps. And unfortunately, there's not much information sent with the trap that will tell you what to do with them. It doesn't exactly tell you who sent the trap. So you either have to put some kind of Wireshark trace on or find out who's doing it. In many cases, I say, if you have lots. I mean, I had one customer call us up many years ago, and they said, look, the system's a little slow. And I went in and they had 2.4 million events in their event database, and 2.2 of those were authentication failure traps. So use them at your own risk. But if you're in a small enough environment and you can find out who is making these requests, do it. That's the way to do it. But if you end up having hundreds of thousands of these, you're in a big company, lots of people are doing monitoring, they may be talking to your equipment without the proper credentials, you may just want to disable them. So the next one, type 5, is EGP neighbor loss. I've never seen it. I could probably look it up and find out what it is. Obviously, it's a neighbor connection loss of some sort. I don't know why that rates one of the 7 generic types, but it does. The one we see most often is a generic type of 6, which is enterprise specific. So you have an enterprise ID and an enterprise specific value of a generic value of 6 says that this trap came from an enterprise MIB. The third credential we use to identify a trap is a specific number. So if an enterprise does send a trap, it has the ability to put a specific number. And these are defined in a MIB. You don't have to make these up, but they should be defined in a MIB somewhere. And when they are, what you can do is put them in OpenNMS. And so a specific type of 1 might be a down, like a disk is down in an array, and then a type of 2 would be that, hey, it's back, it's fixed again, things like that. There are also variable bindings. It is possible to send variables with a trap, and sometimes you have to look at those to determine exactly what's going on with the trap. But every trap should have an enterprise ID, a generic value, and a specific value. So moving forward, let me get back to my slides here. So here's how we send a trap. Okay, so SNMP trap -v1-c public. So let's start with that. Now SNMP trap, if you actually just run it, SNMP trap is in that net SNMP utils package that we installed in the last module. It's in the SNMP package on Unix, on Ubuntu and Debian machines. But it's on CentOS and Red Hat machines, it's in the net SNMP utils package. And what we're going to do is we're going to send a trap. So we'll do SNMP trap -version 1-c public. You use community strings when you send traps. Now, we usually talk about community strings when we're trying to query an agent, but you can actually limit who can send traps. Like the agent has to have a community string in order to send traps. OpenNMS pretty much ignores that. So there's no configuration or anything that you have to do. You can simply just put in public, which is what I do. So that's pretty easy. We're going to send a version 1 trap, and we're going to set the community name to public. Now, this 127.0.0.1 is the destination. So we're going to send it to localhost. So 127.0.0.1 is the destination. And then we have to put in the enterprise ID. Now, in this example, I just made up one. So if you remember from the last lesson, there's about 49,500 different enterprise IDs. And so I just made up 9999999. It'll be a while before I think we have 100,000 enterprise IDs. So I just knew I made it up. And I just made up .2. I didn't made it up. Again, if you actually have a MIB, like OpenNMS has a MIB and there are traps defined in that MIB, we'll actually define what the enterprise ID is there. But for this example, I just want to send something. So .1, .3, .6, .1, .4.1, that's private enterprises. Fix that. 4.1. 99999 is 5 nines is what I just made up, and then 2. I just decided to make a 2 as a type of trap. Now this is usually a class. This enterprise ID usually represents a class of traps, and we want to use the specific value to differentiate between the two. Now this localhost here is the source of the trap. So I'm going to put in localhost. This is just a field that SNMP, send SNMP trap requires. And then the next two numbers are the generic value and the specific value. So we're going to have a generic value of 6 and a specific value of 1. So again, the generic value of 6 is enterprise specific. The value of 1 is just something I made up. And then I have to put these two little ticks. I'd have to look in the SNMP trap. They're just required, and two little ticks is a placeholder. Now, if I sent this in, it would send a trap. I'll just go ahead and do it. Boom. I just sent a trap in. And now if I go to my events, and you'll see I got a new message here, this event 169 in my system. So it was an enterprise default trap. Now this is slightly different than the default event we got with the uei.foo way back in lesson 3. If we just send a UEI in using the send event script, that hits the default. But we know a little bit more about this. We know there's SNMP data associated with this. And so this is why it gets assigned the enterprise default UEI and not just the generic default event UEI. Now I'm going to go back here. I'm going to show you one last thing. You can add variable bindings. So I'm going to, again, this should be defined somewhere, but I'm just going to make up one. .1.3. Oop, I screwed that up, didn't I? 1.3.6. .1.3.6.1.4.1. Because I left off Department of Defense. .1.3.6. .1.4.1.99999. And I'm putting that as .1. This is my variable binding. And again, this 3.1, which I'm adding here, in a normal MIB, if in a real MIB, it would be defined, and it would represent something. In this case, it's going to be a reason. We're going to have a reason code, and in this, so it's going to be a string. So I'll use a type of S, and then I'll put they be bored. What we're going to do is we're going to use this trap to represent that the classroom is in a mood. So I used to do this with beer, but there's certain countries you go to where alcohol is socially forbidden, and so I wanted to do something more generic. So again, the class is happy, the class is unhappy, the class is moody, the class is joyful. We're just going to work with that analogy. So I'm going to send this event in, and as you see, it will also generate. We haven't defined it anywhere, so it will also generate a enterprise default event. If I click on this event 170, you'll see the default event format was used when an enterprise-specific event trap is received with no configuration. And the enterprise ID is that .1.3.6.1.4.1.99999.2. Generic value is 6, specific value is 1, and it sent one argument, one variable binding, .1.3.6.1.4.1.999.3.1, and it's a string with that reason. Make sense? Now, this is very, very helpful. It'll say, now, what you should do is if you are getting unformatted traps, what you should do is actually go and find the vendor's MIB and import the MIB into OpenNMS. We'll have a lesson on just doing that, on importing and dealing with MIB files. But for now, if you wanted to, you could take our normal event, like we had with our class happiness event or our class unhappiness event, and you could add what's called a mask. And in that mask, you define what the enterprise ID is, what the generic value is, and what the specific value is. That's all the import does with a MIB file, is it looks through the MIB file, finds this information, and automatically puts it in this format. But we do try to be helpful in the fact that in the event text itself, we will show you what mask is required to match this event. And this is in the case if you can't find a MIB. I have a Xerox printer right there, and one of the problems it has is it's sending me a trap. I cannot find the MIB for it. So I don't know what the event means. So I could define it here and just put, I don't know what this means, and it gets it out of my enterprise default queue. What I try to do when I do consulting for OpenNMS is I will look for this event and try to configure all of them so that we don't get enterprise default events. And every time we do a release, we tend to add a lot more event definitions as well. So we can do that. Now, so formatting the SNMP traps. It's just like an event, except we're going to add that mask. So I have a file now called classevents.xml. Again, you can type these files in, but I was thinking you might not want to do that. So if you go to www.opennms.org/T training, you'll see this config directory. We're on exercise 7. So we have exercise 7 here. And here's a new class events file. So I'll bring that up. Again, most browsers format XML, so I like looking at the source because it's a little bit easier for me to read. And so here's our happiness event. Here's our unhappiness event. These are the ones that we've had since lesson 3. And as you can see, there's the event tag there. And we define the UEI. Now we're adding a couple more events. So we've got this event here, and here's the mask. So here's the enterprise ID that we're trying to match, the generic value we're trying to match, and the specific value. And if all 3 of these match, we are going to assign the UEI of Moody, that the OpenNMS class is Moody, and then we're going to print in the log message the reason, which is going to be that parameter 1, which goes back to our detail here. And so this is going to print out the reason. Now, first match wins. So when we actually go through this file, so you'll have this ID, you'll have the ID, generic value, specific value of 1. First match wins. So sometimes I'll actually leave one mask which just has the enterprise ID in it, which may say, so I could say, oh, this is a Cisco event, or this is an HP undefined event. Quite often, you can add, into this mask, you can also add variable bindings. A lot of vendors will have a down event and an up event. So a trap will get sent when, say, temperature is exceeded, and another trap will get sent when the temperature is back to normal. Those are easy to deal with. However, sometimes they'll have a status change event, like disk status change. And you'll have to dig into the variable binding to determine what the status is. Did it go from down to up, which is good, I don't need to do anything, or did it go from up to down, which is bad? Well, you can define in your mask, you can add variable bindings as well. So you could say if this ID matches, if this generic value matches, if this specific value matches, and this var bind says the current status is down, well, that's a UEI of a down event. And then you could do the same, where you have the same ID, same generic value, same specific value, but a different var bind match for the up event. And I put those in order. When I make my file, I put those first, and then I might have one without any variable bindings because maybe that's a status I don't know about. So I'll still get a formatted event, but I can say this has an unknown status because it didn't match any of the known statuses that I've predefined. Make sense? I hope so. So anyway, what we are going to do is we're going to go to this file. And again, what I tend to do is I just right mouse click on it, choose copy link location, and then I jump back to my command line, and I'm going to go into the events directory, and then I'm going to do a wget-N, so it'll overwrite the existing class events file, and boom, I've got my class events file downloaded. If I actually look at that file, you'll see that the new events are in there. And now remember, I have to do that reload daemon config. So I will type in my send event reload daemon config for event D, which lets OpenNMS know to go look at that file. It doesn't scan continually to see if the files have changed. So you can edit your file and go to lunch and come back and not do anything until you send this event or until you restart OpenNMS. It won't be read. So you can make sure everything is exactly the way you want it before you do it. So now, here's the down trap. And so here's my ID. Again, I made up the numbers. It has a generic value of 6, a specific value of 1. For my up trap, same thing, same ID, same made up ID, same generic value of 6, but a specific value of 2. So specific value of 1 is the down trap, specific value of 2 is the up trap. Now, I can go back to my screen, and when I send my event, so I send the same event that I sent before, can go and see them now. And you'll see there's a warning level event that says OpenNMS is moody, and the reason is they be bored. Again, this is just an example, and you'll get more useful things out of MIB files themselves, but this is trying to tell you kind of how we take SNMP traps and convert them into UEIs. We do the same thing for any source, like syslog. Syslog, of course, doesn't have an enterprise ID and a specific value and a generic value. They have basically strings, and we use regular expressions. And so we say if this syslog comes in and it matches this regular expression, then assign it this UEI. So as you can think, so UEIs, the unique event identifiers, identify internal OpenNMS events. We can use send event to send those in. But if we get external events, such as traps or syslogs, then we have to convert them to an event which has a UEI to make them useful. Now, demonstrate the up event. When I teach this class, we usually do this on pizza day. So I put they have pizza. So this is the up event. So I'm just going to change the specific value here to 2. You see the difference? Everything's the same except, so we've got this generic value, this ID, generic value of 6, specific value of 1 for the down, 2 for the up. So when I send that in and refresh, you'll see I've got a normal event, class has pizza. Now again, I could add alarm data to these traps, and I can match this as an up with a down with the moody and do things like that. So now that I have this event in, everything that I've done with events before, such as send notifications and do alarms, I can do with traps. Kind of cool, huh? So we do have other event sources. So we have send event for normal events. We have SNMP traps. We can do syslogs. We have transaction language 1, which is the telephony protocol. We have a few examples of that where we'll actually, with TL1, you have to connect to a machine and look at a list of events and then return those to OpenNMS. But we do have the ability to do that as well. So we generated the moody trap, which was this, this first event here. We generated the joyful trap. Both of those showed up as unformatted. We downloaded our class events.xml file, which had that mask in it. And then now we have, they're formatted. So play with this. Feel free to add other variable bindings. You can change the text. You can do lots of cool things. But that's basically SNMP traps. Now we will be revisiting these in another lesson. So I hope that you guys are following along. Again, I have a VM that does these for me. And here I just put all these commands in here just so you have a reference. So again, remember the specific, we just randomly decided that a specific value of 1 would be the down event and a specific value of 2 would be the up event. These will usually be defined with your equipment vendors. And then we demonstrated what it was like to have a variable binding. So that's it. Compared to the last lesson, which was rather long, this is a little bit more involved. But I hope that this served as a good introduction to SNMP traps. And join us again for the next lesson. Again, we are building all this stuff. If you remember, we started off with an overview of OpenNMS, and we installed it, and we created our own users, and then we did events and notifications, and we did alarms, and now we talked about SNMP, and now we've done SNMP traps, and we're just going to build on this. In the next lesson, we're going to talk about service monitoring. So we're finally going to get to that last little section of OpenNMS, service monitoring. Anyway, I hope you guys found this useful, and see you next time.